Hi, my name is Daniel, and today we'll be going over an equilibrium problem. This question comes from problem set 4, question 2. In the equilibrium mixture of hydrogen gas reacting with the chlorine gas to form hydrogen chloride gas, the partial pressure of hydrogen gas is 4.2 atm and that of chlorine gas is 8.3 atm. What is the equilibrium partial pressure of hydrogen chloride gas? Kc for this reaction at exactly 25 degrees Celsius is 4.0 times 10 to the 18. So if we look at what we're given the partial pressure of hydrogen gas, which is 4.2 atm, the partial pressure of chlorine gas, which is 8.3 atm, the temperature at which the reaction is taking place, which is 25 degrees Celsius, and the Kc value, which is 4.0 times 10 to the power of 18. So let's start with making a balanced equation of the reaction, and with the balanced equation, we can use the formula Kp equals Kc times RT to the power of delta N. And then we can use a equilibrium expression to find the partial pressure of hydrogen chloride gas. So a balanced equation would be H2 gas plus Cl2 gas is at equilibrium with 2 moles of HCl gas. Next, we can use the formula Kp equals Kc times RT to the power of delta N. Kp is the partial pressure constant, which is what we're looking for. Kc is the concentration constant that we're given. R is a gas constant, and we're using the value 0.08206 liters times atm over moles times Kelvin. T is the temperature in Kelvin, and delta N is the sum of moles of products minus the sum of moles of reactants that are in the gas phase. So Kp is what we're looking for. Kc is 4.0 times 10 to the power of 18. R is 0.08206 LATM over mole K. And the temperature is 298 Kelvin because 25 degrees Celsius plus 273 gives you 298 degree Kelvin. And then it's raised to the power of 2 minus 2 because there's 2 moles in the reactant side and a sum of 2 moles in the product side. So we can start solving this out. So it's Kp equals 4.0 times 10 to the power of 18 times 24.454 liters atm over mole. And it's raised to the power of 0 because 2 minus 2 is 0. And everything raised to the power of 0 is 1. So we get the Kp is equal to 4.0 times 10 to the power of 18. And with that, we can use the equilibrium expression to find the partial pressure of HCl specifically. So this equilibrium expression is going to be Kp equals the partial pressure of HCl squared, because there is the coefficient of 2 right in front of it, over the partial pressure of hydrogen gas times the partial pressure of chlorine gas. We're given hydrogen gas and the chlorine gas partial pressures, so it's going to be 4.0 times 10 to the power of 18 equals 8 the partial pressure of hydrogen chloride gas squared over 4.2 atm times 8.3 atm. And when we start to solve this out, we get HCl squared equals 1.3944 times 10 to the power of 20 atm squared. We can square root both sides, and that gives us HCl, partial pressure, is equal to 1.2 times 10 to the power of 10 atm. And that's exactly what the question is asking for. So basically, we were looking for the equilibrium partial pressure of hydrogen chloride gas, and we solved it by converting the concentration constant to the partial pressure constant, and then writing an equilibrium expression in order to find the missing partial pressure value.